in this second video, part B, what we're going to do is look at part B in the lab. So we're on page 7, lab 5. And so again, the focus on the video is we're going to do observations to verify Le Chatelier's principle. Nothing different here. So make sure that you remember what's happening whenever there's a system's disturbed. The system shifts in a direction which will minimize that disturbance. So we're going to see if this is true. So what we're going to focus on in this lab again is we're going to set up reactions so they get to an original equilibrium state. And then there's colors that indicate if you're there or not. Then the technician's going to apply a stress. Pay attention to the stress that's being added. Again, change in reactants, change in products, changing the temperature, changing the volume. You'll see that kind of thing. And then finally, you'll see how the system adjusts to relieve the stress and reach a new equilibrium, which may have different characteristics you'll be able to see by color changes, gases given off, solids showing up or going away, etc. All right, so again, before you continue on with this video, you got to be ready. Get your lab book open. We're going to go to lab 5, page 7. Make sure you get your balanced equation ready. So this particular balanced equation, let's look at the balanced equation. This is going to be scheme 6 on page 5. So go to page 5. You're going to see the balanced equation. It looks like this, where you take, again, this is a complex. It's not meaning molarity now. It's signaling you that you have a copper-2 complex. Interesting is that it's complex with water. It reacts with chlorine ions. Now, this might help you understand a little bit, just charge balance. That cobalt hexa aqua complex has a +2 charge, so there has to be charge around to counterbalance it, and so it comes in the form of chlorine ions. So what happens is anytime you add cobalt-2 chloride to water, it makes this complex, and then the chlorine ions are also floating free so that the charge is balanced. And then we're going to treat it with excess chloride ions, sodium chloride. It's going to make this cobalt tetrachloride aqua complex, it's going to make a cobalt tetrachloride complex, not aqua. And this thing is a 2- charge. Still water soluble though, because it's an anion, and it becomes solubilized in the water. It also has to have counterions, so the sodium steps in there to counterbalance the charge on the cobalt tetrachloride, and then the water is knocked off the cobalt, so it comes free. So it's one of the products. Again, pay attention to the colors. On this one, when you're in the red pink, that means the cobalt's back on the reactant side. If you push it to the right or to the product side, the cobalt will go blue, and that's going to indicate which way you are in the equilibrium. So now set up your own equilibrium expression. I'm not going to do this one for you. I want you to practice. But again, I advise you that if it's aqueous or it's a gas, then it could go in the equilibrium expression. But if it's pure liquid or pure solid, it doesn't fit. So you can set that up. Get your balanced equation on the top of your notes. You're about to make observations. Turn to page 7. Look at part B, and let's get started. And the technician will come in and help us with the chemistry. All right, for this particular reaction, we're going to need some hot. So we have a hot bath going over there on the right with thermocouple control. Remember the order in which you set those sorts of things up. Technician's on his game today. He's putting his gloves on first. And then right beside that, it's a little hard to see, but that's an ice bath. We got some of those colored plastic reusable ice cubes, so they're already in the water. So that's a cold bath that's sitting on this side of the hot plate. So away we go. We should be, again, prepare the boiling water bath and prepare an ice bath. That's part B, step 1's done. Okay, what are we going to do first? There's the 1 molar cobalt-2 chloride. create our initial conditions. Find our original equilibrium. We're going to do that by, again, 5 mils. This is quantitative again, so this is it doesn't have to be exact. We're just basically pushing equilibrium around, so we're going to be very close, but we're not setting up a calibration curve. So he uses a lot less detail in trying to clean out, pre-wash his volumetric pipette. These are fresh, they're brand new, and those are disposables. He's also going to dispense all the way out the tip, and again, you never do that if you're trying to set up a calibration curve. That's only in these kind of situations where you're just doing some qualitative work. I could have measured the 5 mil in a graduated cylinder, and that would have been close enough too. All right, so we get that into his beaker. Go. I'm going to start adding sodium chloride to this. Right, step 2. Add 1 gram of sodium chloride to 5 mils of 1 molar CoCl2 chloride. There's your sodium chloride. He's going to get a weighing beaker. So this is a pretty good technique. He can put that on there. If he wants, he can tear that. So there's a button on there. That'll zero it out. That's the tearing button. So now it just weighs 0. So any mass that's added in there is going to be figured out on the scale. It's good. He's going to use a spatula. Again, this doesn't have to be exact, so he's going to, he can, if it's 1.1 or 0.9, that's going to be probably close enough. What we're trying to do is set up an equilibrium where we get it just right so we can play with it a little bit, move it back and forth from left to right. So that's why we have to be kind of set these up this way live. Take a look at things. Okay, good. Hey, hit it right. Well, a little over 1 point. And this is good, because remember what we say, we read every digit off the face. And so when you were looking at that, you were seeing 1.00, then it kind of hit 1.01, and then it was 1.02. So that's correct, that's where it varies. All right, so let's add that to the CoCl2 chloride. Now this would be a good time if you have what's called a glass stir rod. If you have even that metal spatula, if that was, that's okay, you could use it. You can just swirl like the technician's doing there, that's okay. Put a magnetic stir bar in there and put it on a separate stir plate. There's a lot of ways you can mix that up. Okay, but now this is the standard equilibrium solution, so everything we're going to do is basically going to hinge off of that particular reaction. So step 3, split the solution into 3 test tubes. We're going to have a 1/2 mil, 2 mil, and 2.5 mils. So if you do the math on that, that's where our 5 mils are going to go. And again, we're going to mark them 1, 2, 3. Test tube 2, the one that has 2 mils in it, that's going to be our color reference. So anything that happens from here on out, we'll be able to reference it to color 2 and see what that looks like. And again, if you're taking screenshots of this, you don't want to take the screenshots when it's in the beaker or in the volumetric pipette, because it looks, and this is a good example, see where he pulls it up and it gets in that thinner tube? It looks like it's more dilute, but it's not. It's just that you're looking through less width of the fluid. So if you have less path length for the light to travel through, it's going to do less absorbance, if you can think of it that way. So he's loading it all up into that volumetric, and then I think what he's going to do is walk his way through the tubes and just dispense the different amounts. We'll see. So here comes tube 1. It's not much, just a little 1/2 mil in there. Here's tube 2. This is going to be our color reference. This is going to have the 2 mils in it. Still working on step 3. Remainder goes in tube 3, roughly 2.5 mils. Or he should, if he had mixed, if he pulled all the way up to 5, he should be able to just drop all the rest of that in there, and that should be right. All right. Good job. Also, again, better technique than the last video. Came in wearing his gloves. Good on you there, John. There's Jonathan. There's Jonathan's left ear. All right. I'm not sure what he's doing there, but some sort of adjustment. So here you go. There's the 1/2, the 2. The middle one's the color reference. So if you want to take a shot of that, that's your color reference. The right one is test tube 3, and we're going to do different reactions with all 3 of those. We're going to see if we can push equilibrium. So the reason we have gloves, the reason we're in the hood, is we're actually going to use concentrated hydrochloric acid. And that's actually supposed to go in to tube 1. If there's anything, so think about this, we're pushing chloride. We're going to add extra chloride ions to it. We'll see how dramatic this is. And actually it may pull it off, but he made a mistake, because really he's supposed to be adding concentrated, not 6 molar. But we'll see if it works, see if it pushes the reaction. It looks like it is. Let's see it getting, yeah, it's a good strong color change. That's good. Now that little pipette, that's never been anywhere except in the HCl bottle, so that's okay. Do a mix of that. So that's 4 drops of concentrated HCl. Now look at this. Look at the color. Now he's going to drop it into the cold ice bath. Now, work on his hand placement. There he goes. All right. So this is kind of interesting if you can watch this. Went really strong blue, and now it got cold, and see how it, where it's chilling off, it kind of pushes it back to that purple. So this is where you can see how he's pushing equilibrium. Now he's going to go into the hot bath and see what happens. this is going to be real instructive. Looks like when he's going cold, it's pushing it back to purple. Now he's going to get it nice and hot, adding heat. And looky there. Oh, that pushes it strong to the blue side. All right. Now, it's important at this point that you just kind of notice a little bit of technique, and that is that you're pushing a test tube from a cold bath over to a hot bath, so that has to be a special kind of glass. That has to be either Pyrex or Chemex, or you're going to have big trouble. So he's going to go back and forth. If you're doing this with glassware at your house, you're just using a wine glass or something, it would shatter going from that hot to the cold, but we can get away with it here. So this is fun. Look at it change. He's pushing equilibrium, getting it cold. Be patient. Leave it in there. Come on. Come on. You see a little bit. I wish he'd put it back in there and let it sit for a little longer, because you'll get it. It'll push more equilibrium if you leave it in there. You could start to see the bottom turn purple. Now he's going back to the hot side. So anyway, the point is that equilibrium's, every time you change the temperature, it changes the equilibrium like we've talked about in class. That's dependent on whether it's endothermic or exothermic, the reaction, but this will give you a hint. Wow, look at that, goes blue. Now he's going back cold. Right where those tips touch those ice cubes really is where you'll see it, but if you leave it in there long enough, there you go, swirl, swirl, that's good. Be patient. Oh, Jonathan, you're not very patient. It's a little, you can catch a little purple in the bottom. Okay, so that is all the way through 7, 8, where they've repeated. Now what we're going to do is we're going to just go and take that third test tube and just put it in the hot bath. Well, so let's just see if, independent of having any kind of, there we go. So remember what we did.
Good.
Oh wow, looky there.
I have to admit the color isn't too visible on the video, but I
Pushes it hard.
I do see it in person.
And then if you'll let it cool, and he's letting it just kind of cool off in the room, it'll start to shift back on its own.
Yeah, and boy.
Now he's going to plunge it into the cold bath.
Oh, good.
This is a really good reaction. This will be a little bit more dramatic.
Checking in the temperature. Good.
Looks like somebody.
Yeah, this is the clear one.
That was probably Dr. Thompson without gloves. I think what I was telling him is move it away from the blue cube. There
oh, perfect.
You go.
When I hold it
there you
against
go.
the
white
that's
background
the
that really
perspective,
pops. Okay, so that definitely pushes that coal pushes it back to the red side. Hot.
Good.
So this one was a little bit more on the border. So now when you go between the hot and cold, it really pushes hard to the right and hard to the left. Get it hot. Ooh, look at that. That is beautiful. Man, I wish you'd set that over that white background. That would help us. Thank you. That is just as dark as it can be. Put it back in the cold. Again, it's kind of hard to see the perspective because you got blue cubes. That was a bad choice on our part. Probably should have chose some different colors to put in there so it wasn't taking us out. But if you cool it down, then pull that out and set it over the white background. It's pretty obvious. Yep, that's a good pink color. Pinkish red. Good. All right, so I hope this helps you, and you'll have to just kind of take your clues that you've learned from when you put it in the cold, it goes to the red side. When you put it in the hot, it goes to the blue side. So that should be all the clues you need to know to figure out whether this thing is exothermic or endothermic. So you are done with video B, and you can move on to the next video. Again, you might want to run these back, take some screen capture so you can get the before and after and see how things were stressed.